Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay. So today it's a Sunday special class and I'm going to discuss atomic and molecular physics. Okay. So I'm sure in 4 lectures I'm going to complete atomic and molecular physics. Each lecture is going to be of 2.5 hours. Okay. Okay. So this is the first lecture of atomic and molecular physics. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay. And also guys, please share my details, lecture details to your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay guys, so let's get started. Okay. Meanwhile, just let me check whether I'm audible or not, then I'll proceed further, okay? 5 hours, okay? Yes, I'm audible, so I'll proceed further. Okay, guys. Okay, so atomic and molecular physics. Atomic and molecular physics, okay? Atomic and molecular physics, which we are going to, which I'm going to discuss, okay? Okay, guys, so okay, guys, so first I will explain what is the difference between hydrogenic atom and hydrogen-like atom. Okay, so hydrogenic atom. Okay, hydrogenic hydrogenic atom. Hydrogenic atom. So hydrogenic atom means one electron system. Okay, one electron system. So those atom uh, who has one electron, who has one valence electron. Okay, one valence electron, that is the in outermost shell, there is only one electron. Okay, so that is the hydrogenic atom. Okay, so we can take example of sodium, right? So there is one atom, right? So outermost the electron in outermost shell is one. That atom is called hydrogenic atom. Okay, now hydrogen like atom. Okay, H like atom. H like atom. So hydrogen like atom means those atoms who has only one electron. Okay, like for example that hydrogen, so we can take hydrogen, this it has only one electron. Okay, and so hydrogen itself hydrogen, right? So that is helium. If we talk about helium plus 1, right? Helium plus 1 has only one electron. Okay, so it is one electron, so it is hydrogen like atom. And we can take example of lithium plus 2, and beryllium plus 3, beryllium plus 3, etc. So these are hydrogen like atom. Okay, and this is hydrogenic atom means the atom whose the outermost means there is only one electron in the outermost shell of an atom. Fe equal to FCF. Okay, so in this case, that Coulombic force is equal to centrifugal force. I'll show you this in next page. Like we have This is a hydrogen atom, okay, or ZE. Okay, this atom, and the electron is revolving around it. Okay, okay, this one. Electron is revolving around it, and the radius of orbit is r. Okay, so in this case, because electron is moving in circular path, right, or in electron is moving, right, and this is the plus charge. Okay, and the radius is r. Okay, so in that case, so because electron is moving around the nucleus. Okay, and you can see, and and because it is moving continuously because of two forces. Okay, the electrostatic force, that is Coulombic force, uh, uh, right, and Coulombic force, and there is a centrifugal force as well. Okay, so in that case, F equal to, that is F is Coulombic force, that we have already studied in class 11th and 12th. F equal to FCF, okay, centrifugal force. Centrifugal force will be towards outside, right, radially outward, and this Coulombic force will be radially inward. Okay, so, and since we know that Coulombic force F equal to K Q1 Q2 upon R square, right? Q1, this is the charge of electron, and this is charge of this nucleus, right? So this is going to be, and centrifugal force we know CF, that is centrifugal force CF. Centrifugal force CF is mv square upon R, right? mv square upon R. This one centrifugal force, and which will be radially outward, right? That V is the velocity of electron, m is the mass of electron, r is the radius of this this orbit, right? Okay, so in that case, because this is balancing this, right, the Coulombic force is balancing centrifugal force, that's why electron is continuously moving around the nucleus, right? So it means, that implies K is that K Q1 Q2 upon R square equal to that mv square upon R. And since we know K is here, K value is, I can write here as well, value of K is 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0, right? This is the value of K. Okay, so from here we can get this one. This implies mv square equal to K, R will get cancelled, right? Kz E square upon R, right? This is important one, right? This one. Okay, now this is the postulate first. Okay, so electron is moving around in circular orbit, okay, around the nucleus, or in case of this hydrogen, so this is around the proton, right, nucleus, and we can see that because because of two forces, the electron is moving continuously around the orbit, right, and that is centrifugal force is balancing, that is Coulombic force. Okay, so from here we have got this value. So this is the postulate number first. It's Bohr's atomic model. Okay, and I'm discussing. So second postulate is electron revolves electron revolves in a specific orbit, specific 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 orbit. Electron revolves in a specific orbit for a particular value of angular momentum. Value of angular momentum. Okay, so electron revolves in a specific orbit. Okay, so it revolves only specific orbit. Okay, so those orbit for a particular value of angular momentum. Okay, for which the value of angular momentum is that a particular value of angular momentum. Okay, for example, like I'll explain this one. Like, so L equal to mvr. Okay, mvn, that is equal to n h cut. Okay, so this is important point, guys. So electron is revolving on only on those orbits whose angular momentum is this equal to n h cut, where n values are n equal to 1, 2, 3, 4, so on. Okay, n equal to 1, 2, 3, 4, so on. Okay, so electron revolves only on those orbit, only on those orbit who have that particular value, who has the value whose angular momentum value is n h cut. Okay, n is the value of n is 1, 1, 2, 3, so on. Okay, integer. This is the postulate second. Postulate third is in a stable orbit, in a stable orbit, in a stable orbit, in a stable orbit, electrons in a stable orbit, electrons energy, this is also very important point. So in a stable orbit, so I'm talking about the stable orbit. Okay, electrons energy remains constant. This is very important point. If it is not if this electron's energy will not remain constant, in that case that electron will keep on moving, and finally it will attract by the this nucleus, or positive nucleus, right? It will be attracted by positive nucleus. Okay, but that doesn't happen, right? So that's why in a stable orbit, electrons energy remains constant. Okay, this is important point. Energy changes energy changes when it makes a transition makes a transition from one orbit to another, from one orbit to another. Okay, so in a stable orbit, electrons energy remains constant, and energy changes when it makes transition from one orbit to another orbit. Okay, so this is the one. This is positive nucleus. These are the orbit. In these stable orbit, electrons energy remains constant, okay, and it changes when they make transition, okay, from one orbit to another orbit, okay. This is the postulate third. So here I can show you this one. So these are energy levels, okay, energy level N1 and N2, okay. This is energy E and this is energy minus E, okay. So E equal to H nu, energy we have given this, okay. So this energy is absorbed by the electron and then it excites and goes to this level, okay. So this is absorption, that this is called absorbs photon, okay. absorbs absorbs photon, okay. Absorbs photon. Absorbs photon, right, and then gets excited. And also here you can see these are energy levels N2, N1. In this case there is a electron, okay. This de-excites here, okay, goes to this level. This jumps from higher level to N1 to N1, okay. This electron and releases photon. So here you can see that electron absorbs energy and gets excited and goes to a next level, right. And in this case that electrons emits, or electrons de-excited and comes from N1 to N2 and releases the photon of energy H nu. This is N means emission of electron, okay. So so in this case E, that energy is going to be H nu, and that H nu is going to be equal to E and 2, the difference of this energy level, okay, difference of energy of the energy levels, right, that E and 2 upon E and 1, difference of energy levels, okay. So suppose the energy of this level is E and 1 and this is E and 2, so the difference of energy is going to be E and 2 minus E and 1, right, and that is equal to H nu, okay. So I'll give example also. Here you can see, suppose these are two energy levels. This is the energy level whose energy is 3 electron volt, and for this level the energy is 5 electron volt, right. So here electron, so here H nu equal to 2 electron volt, okay. So we have given 2 electron volt energy, okay, to this electron. So there is an electron, okay, and it gets excited and goes to this energy level, because the energy difference of these level is 2 electron volt. So if 2 electron volt energy, if we give this electron, so this will excite and will goes to this energy level, okay. And the energy must be that H nu must be equal to the energy difference. This is very important one, guys. If energy less than this or more than this, in that case it will not get, an electron will not get excited, okay. So so this is the one. Suppose if energy is H nu is 3 electron volt, 3 electron volt or 1 electron volt, in that case no absorption. Electron will not absorb the energy and will not get excited. Okay, so energy must be equal to the energy difference. So h nu, that is the energy. So here these are two energy level, right? And the difference is 2 electron volt. If we give 2 electron volt of energy to this electron, right, to 2 electron volt of energy, that then this electron will absorb this energy and will goes to this excited the next excited state from here to here. Okay, I hope guys you have understood it. Okay. Okay guys, okay, next point. Next is ionization energy. Okay, ionization energy. So what is ionization energy, guys? Ionization energy is the energy which is required to eject electron from any orbit of atom. Okay, and to completely eject that electron from this atom. Okay, and that electrons become free. Okay, so that is the that is ionization energy. So minimum energy required to eject electron from the atom. Okay, so suppose this is the positive charge. Okay, and this electron here, and these are orbits of electrons, orbits of this atom. Okay, there is electron, there is also electron, right? So to eject electron completely from the atom, the energy required from the orbit, or we can say the electron require the minimum energy required to eject electron from the orbit completely is called the ionization energy. Okay, so for this an ionization energy is negative. Okay, because there is a bounded, there are valence electrons, right? Okay, so here in this case n equal to ni. Okay, and ni to nf, that is equal to infinite. So for or we can say the for the minimum energy required to eject electron from any orbit of the atom to the infinity orbit, or infinity to the orbit who has nf equal to infinity. Okay, so orbit to the infinity orbit, we can say. Okay, so here you can, like, I'll give example. So this one we have n equal to 1, and this is n equal to infinity. Okay, so this is so if you talk about ground state of hydrogen atom, right? So there is a electron. Okay, we have given energy h nu, that is equal to h nu, which is h nu equal to h nu h nu equal to, that is 13.6 electron volt. Okay, so we have given this 13.6 electron volt energy. Okay, and to eject that electron, and then this electron then the electron will be ejected, and that then it goes to the orbit, infinity orbit, right? Nf equal to infinity, to this orbit. Okay, this one. So this is called the ionization energy. For hydrogen atom, the ionization energy is 13.6 electron volt. Okay, to completely emit electron from the orbit of the atom. Okay, okay, so you need to understand for valence electron. Valence electron means the outermost electrons. The electrons. Valence electron means those electrons or we can say outermost electrons of the atom, okay, which are at outermost orbit. Okay, so that valence electron of the atom, that is for that the kind of that potential energy will be minus V, because they are bounded electron. Okay, if potential energy is if potential energy is minus V, means negative, in that case electrons are, if potential energy is bounded, means negative, it means the electron is bounded, right? Okay, so for valence electron, those are bounded electron, right? So for their potential energy is in negative. Okay, and if you talk about free electron, so if you have free electron, for that the potential energy P, that is going to be greater equal to 0, either 0 or greater than 0. Okay, for free electron. For bounded electron, potential energy is negative. Okay, valence electron means outermost electron of the order of an atom. Okay, now radius. Radius of atom. Okay, radius of this orbit. So radius that we know that mv square equal to kz e square upon r, right? This one, call this equation number 1. Okay, this we know from postulate 1, mv square equal to kz e square upon r, kz e square upon r. So in that case, so this is from equation 1 we've got this, right? And now, and also from postulate 2 we know mvr equal to nh cut, right? So from here we can get the value, that is v equal to nh cut upon mr, right? So what we can do is we can put this value, this is equation number, from equation number we've got, right? So putting this value of v, okay, this is you can say value of v in this expression. So this is going to be, in that case, value of r is going to be this kz e square upon, this will come here, right? So this is going to be mv square, right? mv square value is this is nh cut upon mr whole square. Also guys, we know h cut value is h upon 2 pi, right? So that value of r is going to be kz e square upon m into this one. This is the one. Kz is this. If we solve it, so this is going to be this way, right? Okay, this one. If you solve it, right, and if you put value of h cut equal to h upon 2 pi, so r value we are going to get, this is h square, simple calculation, h square upon 4 pi square k e square m, okay, into n square upon z. Value of r is going to be h cut square, again we have put this one h cut square, the value is going to be h cut square, h cut equal to h upon 2 pi, okay, m ke square into n square upon z, or we can write rn or r, that is this value is going to be, this value is constant, and that value is almost equal to 529 0.529 into n square upon z. Okay, so Rn is proportional to n square upon z. This is very important one, guys. You need to note down. Okay, we will solve many questions. So this formula is important. Rn means radius, or Rn is proportional to n square upon z. Okay, or R is proportional to n square upon z. Okay. Okay, guys. Next is, so this is for one electron system. Okay, one electron system. Rn proportional to, or R proportional to n square upon z. Radius is proportional to n square upon z. Okay. Next is velocity, guys. Velocity. Velocity Vn or V, that is equal to this one, 2 pi kz, 2 pi kz e square upon nh. Okay, or Vn equal to ke square upon h cut z upon n. Okay, so this one. So this is the Vn value. So from here we've got the Vn value, guys. Yeah. V value, right? V value is going to be mr, right? This one. So this is the one. Okay, so this is important result, guys. So from here we can get Vn value. Vn value is going to be this, if this constant. So 2.18 into 10 to the power 6 z upon n. Okay, so this is also important result, you should know. Okay, so that implies Vn is proportional to z upon n. This is very important result, guys. Okay, you need to note down and you need to memorize it, guys. Vn or V is proportional to z upon m, and this one Rn is proportional to n square upon z. Okay, very important one. We will use these this formula for solving questions. Okay. Okay, next is similarly, so here also we can see that velocity is independent of mass. Velocity, there is no term of mass, right? Velocity is independent of mass. Velocity is independent of mass. Okay, next is angular speed. Angular speed, that is omega n is proportional to Vn upon Rn, right? This we know, V equal to R omega, right? So omega n equal to V, this we know, right? V equal to R omega. So omega n equal to Vn upon Rn, right? So from here, omega n is going to be value, that is going to be 8 pi square, my apologies, 8 pi cube k square e to the power 4m upon h cube z square upon n cube. Okay, this is the omega n. So from here, omega n, that is angular frequency or angular speed, is proportional to Z square upon N cube. This is important result, guys. You need to note down. Okay. And similarly, frequency is proportional to this angular frequency, right? So frequency is going to be frequency, that is Fn, that is also going to be proportional to Z square upon N cube. Okay, this is also important. Similarly, we can find time period. Time period is, we know, 2 pi by omega, right? So from here we can see time period. Okay. Time period T is 2 pi by omega, or we can write time period is proportional to Z square upon N cube. This is as Z square upon N cube, and this is going to be N cube upon Z square. My apology. Okay, so this is N cube upon Z square, inversely proportional. N cube upon Z square. This is also important. T proportional to N cube upon Z square. N cube upon Z square. Okay, N cube upon Z square. Next is current. Okay, so due to electron revolution, and nth orbit, due to electron revolution and nth orbit, we know In, that In is going to be E upon Tm, right? That is time period, right? So from here we can get E into Fn, right? E into, because T equal to, here T is 1 upon F, right? So this is EF, or so this means, this implies I is proportional to Fn, or that is proportional to Z square upon N cube. Z square upon N cube. Z square upon N cube. Okay. Next is magnetic field. Magnetic field okay. So magnetic field formula that we know, guys. Okay, so this is B equal to mu 0 In upon 2 Rn, right? And Rn and In and Rn value we know, right? So from here In is going to be proportional to Z square upon N cube. Z square upon N cube. Okay, and we know, and Rn proportional to N square upon Z. We can just put the value here. N square upon Z. Okay, so from here the value Bn is going to be proportional to, for nth orbit, okay, that is Z cube upon N to the power 5. Okay, this is also important results. These results you need to note down, guys. Okay, next is energy. energy. Next is energy. Okay, energy is En is Kn plus Un, right? That energy is that kinetic energy plus potential energy. Un and Kn are kinetic energy and potential energy respectively, right? So from here, that U value is going to be a new value. We know this is that K Q1 Q2 upon R, and also kinetic value we know, kinetic energy we know, that is half mv square, right? So from here, so we'll put the value, right? So En is going to be half mvn square plus k ze into minus e, okay, because z is the charge of nucleus and e is the charge of electron, right, upon Rn. And so En is going to be, this is half mvn. We can write mvn value we already know, right? This is k ze square upon Rn, right? And minus this is kze square upon Rn. Kze square upon Rn, right? So from here, if we solve this one, this is going to be En is going to be equal to value of En, that is going to be equal to this one, minus half k ze square upon Rn, okay? So from here, okay, kze square upon Rn, and this one, okay. Rn, okay, here makes mistake, so this is n is gone, guys, okay. This is half kz after putting value of En, okay. So this is going to be this one, right? So that's why the value is half kz, because this is kze square upon Rn, this is half kze square upon Rn, right? So this is minus half kze square upon Rn, or we can write this as like this, mod of total energy is equal to, this is kinetic energy, mod of kinetic energy, this one, mod of kinetic energy, and equal to 1 by 2 mod of potential energy, this one, right? Okay, so this is the important result, guys, you need to note down. Next is for z equal to 1, or we can write this one is also important, okay? And this also implies value of En is minus m e to the power 4 k square upon 2 h cut square z square, this one, guys, my apologies. this one. Okay, so here, yes, value of En is minus m e to the power 4 k square upon 2 h cut square z square upon, we have put the value of this Rn, right? Z square upon n square, z square upon n square, and En value that is going to be equal to this. If we calculate this, this is going to be minus 13.6 z square upon n square electron volt. Okay, this one. This is important result, guys. You need to note down this one. En equal to 13.6 n square z square n square electron volt. Okay, z square n square electron volt. Next is, so if you solve for, so from here we can get, you can see we have this one, right? So En is proportional to z square upon n square. This is very important result again. En is proportional to z square upon n square, z square upon n square. Okay, this one. So this is also very important result. You need to know these results: Rn value, Vn value, and En value. Okay, so Rn is proportional to n square upon z, Vn is proportional to z upon n, and En is proportional to z square upon n square. You need to note down and memorize it, guys. Then you will be able to solve question easily. Okay. Next, and here also, if n equal to infinity, in that case En is going to be 0. Okay, and for z equal to 1, E1 value is going to be minus 13.6, because z is 1 and z is 1. Okay, for z equal to 1, and for, okay, for we are talking about hydrogen atoms, so z is obviously 1, and for n equal to 1. Okay, for n z equal to 1 and n equal to 1, En is going to be 13.6 electron volt. Okay, we just put the value here. 13.6, z is 1, n is 1, right? So 13.6 electron volt. Important result, this one. Okay, and for n equal to 2, for n equal to 2, E2 value is going to be minus 3.4 electron volt. Okay, and for n equal to 3, E3 value is going to be minus 1.5, minus 1.5, minus 1.5, 1.51 electron volt. Okay, and if you talk about the gap, energy difference between E1 and E2, that is 10.2 electron volt. This is the difference. Okay, delta I, 10.2 electron volt, and this difference is 1.89 electron volt. Okay, so these are the results for, this is for En. This is very important. Okay, next is Rydberg scale of energy. Okay, Rydberg scale of energy. Rydberg scale of energy. Rydberg scale of energy. Rydberg scale of energy. Okay, so this is that En is, that value we know, right? This is m minus m e to the power 4 k square upon 2 h cut square z square upon n square. Okay, so what we can do is we can multiply by SC and divide by SC. Okay, S is Planck constant, C is the velocity of light. Okay, so from here this is going to be this one, 2 pi 2 pi square k square e to the power 4m upon ch cube, okay, into hc z square upon n square, where we have put h cut value h upon 2 pi. Okay, so this is the value, guys, En, and this value is Rydberg constant. Okay, R, this is R. Okay, so this value is going to be, this is R, this is R. Okay, so from here En is going to be minus R hc into z square upon n square. Okay, this is also important result. Okay, so this is the value of R. So R value is this one. This is the Rydberg constant. Okay, so 2 pi square k square e to the power 4 m upon ch cube. Okay, and here the value of R is 10 to the power 7 m inverse. Okay, or equal to 1 point, or we can write 1919677 centimeter inverse. Okay, this is the value of R, and also we know if z equal to 1 and n equal to 1, then value of En that is minus 13.6 electron. Okay, so R is 2 pi square k square e to the power 4m upon ch cube, that is Rydberg constant. Rydberg constant. Rydberg constant. Okay. Okay. Now you can see this is also, we know R is proportional to m, guys. This is very important result. R is proportional to m means Rydberg constant is proportional to m, that is mass. Okay, reduced mass. Okay, and also R infinity is proportional to m. So Rydberg constant, R infinity is the Rydberg constant corresponding to mass whose mass is infinite. Okay, compared to the mass of electron, and so R infinity is proportional to me, that is mass of electron. Okay, and R is proportional to Rydberg constant for finite mass whose nucleus mass is finite. For that, R is proportional to m, that is R is proportional to reduced mass. Okay, here I'll solve it here. Okay, so you need to understand this. Okay, when okay, so next is when we assume nucleus mass to be infinite, since Me is greater than Me is less equal to mass of nucleus, okay, Mn, or mass of nucleus we can write. Me is less equal to mass of nucleus, and that is a mass of nucleus is almost equal to infinite. Okay, so in that case the Rydberg constant is R infinity. So like this is the nucleus, M nucleus, okay, and which is at rest, and electron is moving around it, and mass of nucleus is very high compared to the electron. So in that case we can consider mass of nucleus is infinite, okay, because it's very high, very less, very high, extremely high, okay, compared to the mass of electron. Okay, so here also you need to know if this is the one, okay, so the mass of nucleus is infinite, so in that case there would be Rydberg constant, and that would be denoted by R infinite. Okay, so if mass of nucleus is finite, if mass of nucleus is finite, in that case the reduced mass, that is mu, is going to be equal to Me Mn upon Me plus Mn. Okay, so this is mass of nucleus or mass of electron. So this is the reduced mass, guys. Okay, this is the reduced mass, that is M. Okay, so reduced mass mu is Me. If this one, okay, if mass of nucleus is finite, in that case we'll talk about reduced mass. We'll consider reduced mass, and that is equal to mass of electron into mass of nucleus upon mass of electron plus mass of nucleus. Okay, so this is the reduced mass formula, very important formula, guys. Okay, well, and so if Mn is infinite, in that case mu is going to be reduced mass mu, that is going to be Me, or we can write this like this, okay, Me upon we can take Mn in the denominator, so this is going to be Me into 1 plus Me upon Mn. Okay, so we have divided this by Mn and divided this by Mn. This value is 1, this value is Me upon Mn. Now mass of Mn is infinite. Okay, so in that case Me upon 1 plus 1 upon infinity, right, and 1 upon infinity is 0, means Me. So if a mass of nucleus is infinite, in that case reduced mass, I can denote this with this E, mu E is going to be equal to Me, mass of electron. Okay, this is very important. If Mn is infinite, if Mn is not infinite, in that case reduced mass is this, or if it is infinite, then reduced mass is, I can denote this by E, mu E, that is going to be equal to Me. Okay, Me. So from this we can imply this one, since mu E is proportional to Me, we can say, so in that case R infinity, that is Rydberg constant, is proportional to mu E. Okay, this one, because Rydberg constant is proportional to Me, I have shown you here. This one, Rydberg constant is proportional to Me, and R is proportional to M, that is reduced mass, right? So from here, this mu E from here mu is proportional to me, okay, and R is proportional to mu, R infinity is proportional to mu e. This is very important formula, okay, you need to know that. Next is I'll explain Lyman series, Balmer series, Paschen series, bracket series, and fund series, okay. So these are going to be like this. This one, okay. So n equal to 1, this is energy level, okay. N equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 5, okay. So I'll show you different energy levels, right? So, okay, so if energy, so these are the energy levels, okay, and from if energy is going from n2 to n1, okay, or n3 to n1, energy is going from this one n5 to n1, okay, and then n4 to n1, n3 to n1, and n2 to n1, okay. So if energy this is the electrons are coming, right, from n1 and n2 level to n1, or n3 level to n1, n4 level to n1, and n5 level to n1, and so on, okay. So this is called, this is the Lyman series with all there is a de-excitation of electron, okay, from n2 to n1, n3 to n1, n4 to n1, so coming on n1, right. So this is the Lyman series, guys, okay. This is the transition, okay. This is Lyman series, and also this is called Lyman series, Lyman Lyman series, okay. Lyman series. Next is if transition, all transition are happening in level n2, like from n5 to n2, okay, from n3 to n2, and from n3 to n3 to n2, right. So this is the this is H alpha line, H beta line, like this, okay. So this is called Balmer series, okay. If transition are happening on n3 level, okay. So this is, we need one more level also, okay. So suppose this is the n6 level, guys, okay. This is n6 level, this is one, okay. this one, then this one. Okay, this is the Balmer series. Okay, Balmer series. This is n equal to 6. N equal to 6. Okay, n equal to 6. Now, for Paschen, all transition are happening at n equal to 4. Okay, this is n equal to 2. This is Balmer. So, and then the Paschen n equal to 3. Right. So this is going to be like this. 3. This one. This is Paschen series. And next is bracket. All transition are happening at 4. N equal to 4. Right. So this one. This is bracket series, right? And then fund series. This is n6 to n1. Okay, this is fund series. FUND. Okay, fund series. These are the Lyman. This is Lyman series. All transition are happening at n1 level. Okay, from n1, from n2, n3, n4, n5, so on, and all transition happening to n equal to 2. For Paschen, all transition are happening at n equal to 3, and for bracket, all transitions are happening at n equal to 4, and for fund series, all transitions are happening at n equal to 5, from n equal to 6 to 5, n equal to 7 to 5, n equal to infinite to 5. Okay, 5. So these are the different series. This is Lyman series, this is Balmer series, this is Paschen series, this is bracket series, and this is fund series. Okay. Well, next is so here we can like L alpha line. Okay, this is L alpha. Okay. So for L alpha, the transition will be Ni will be 2 and NF will be 1. So NF will be 1, that final position, right? NF will be 1. So from Ni, from 2 to 1, if transition is happening from n equal to 2 level and n equal to 2 level to n equal to 1 level, right? Then this is L alpha line. Okay, Lyman series. And L beta means Ni value is 3 and NF value is 1. So transition is happening from n equal to 3 to n equal to 1. This is called L beta. Similarly, H alpha line is Ni equal to 3 to NF equal to 2. So the transition is happening from, this is Balmer series, okay, from n equal to 3 to n equal to 2. And similarly, H beta line, right? That is for Ni equal to 4 and NF equal to 2. This transition is happening from n equal to 4 to n equal to 2. This is H beta line. Okay, so similarly we can get all other lines. Okay, now I'm going to solve one question first. Okay, the question is, okay guys, just give me 1 minute, right? Okay. Okay guys, so I'll start now. Okay. Okay, meanwhile, just let me check whether I'm audible or not, then I'll proceed further. So reduced mass, mu is, yes, I'm audible, so I'll proceed further. Question is, which energy level, which energy level, which energy level, which energy level of triply ionized, okay guys, just give me 1 second. Okay guys, which energy level, of triply ionized, triply ionized, triply ionized Be plus 3 has the same electron orbital, radius as of ground state of H atom. Options are option A, n equal to 2, option B, n equal to 3, option C, n equal to 4, and option D, n equal to 1. Okay, so the question is, which energy level of triply ionized, beryllium plus 3 has the same electron orbital radius as of the ground state of hydrogen atom. Okay, so this is the question. Very good question guys. So I have already explained this one. Be plus 3, that is H-like atom. H-like atom means it has only one electron. Okay, H-like atom as hydrogen. Okay, and I have already explained Rn value is, or Rn is proportional to n square upon z, right? This we know. So so from here we can write radius of hydrogen atom at ground state is equal to radius of beryllium atom, Be plus 3. Okay, and so this is going to be for this beryllium for n equal to n, and for z equal to this, for beryllium atom z equal to 4, right? For hydrogen atom n equal to 1 and z equal to 1. Here we have this formula, this, or we can write z equal to this one, Rn equal to, so also I have explained 5.29 n square upon z square, right? This is the formula. So for suppose for n equal to n level, okay, beryllium atom has the same radius as that of ground state of hydrogen atom. Okay, so in that case this value we can write 0.529 into z square upon n. N square upon z means 1 upon 1. That is going to be equal to 0.529 into this value, radius of this is going to be z square is n square upon 4, right? N square upon z square means n square upon 4, sorry, n square upon z. This is n square upon z, right? N square upon z. We made mistake. This is n square upon z. So this is the one, right? So this will get cancelled. So n square value is going to be 4. So n equal to 2. For it means for for beryllium atom whose energy level is n equal to 2, that one radius is equal to the radius of ground state of hydrogen. Okay, so option A is the correct option. This is the answer. Next is next guys, as we know this formula, E equal to, this is important one, E equal to minus RCH or SC Z square upon N square, right? That is in joule. Okay, so this is important formula. So from here we can get E electron volt. E electron volt, sorry, means it is energy in joule, and energy in electron volt we can find. There is a formula. Energy in electron volt is equal to energy in joule upon Hc. Okay, this is important formula, guys. You need to note down. Energy in electron volt is equal to energy in joule upon Hc. Okay, H is Planck constant, C is velocity of light. Okay, this is, we can say, conversion of energy in electron volt to energy in joule, right? Conversion of energy in electron volt to energy in joule. Okay, conversion of energy in electron volt to energy in joule. Okay, next is, so this is like, this is EI and this is EF, NI and NF. Okay, so here this one, EI minus EF, that is equal to minus RCH Z square Z square upon NI square minus, because this one, okay, minus into minus RCH Z square upon EF, right? So NF square, right? We can write this. This is the energy level difference. Okay, so because value of E we know it, right? So EF is this NI square and EF is NI NF square, right? We can write like this. So this value is going to be now, this value is, we know, right? This is energy difference, right? Delta E, that is equal to H nu. Okay, so that is going to be, we can take RCH, we can take minus RCH as a common, then Z square into 1 upon NF square minus 1 upon NI square. Okay, this is the one. 1 upon NF square minus 1 upon NI square. So from here HH will get cancelled. Okay, so nu is going to be nu is going to be 8 equal to minus RCH z square into 1 upon nf square minus 1 upon ni square. Okay, and v upon c equal to minus r z square into 1 upon nf square minus 1 upon ni square. Okay, this one, or c upon this value is nu bar we can write, or this is 1 upon lambda. Okay, so 1 upon lambda, so 1 upon lambda is going to be equal to r z square into minus will take inside, so this is going to be 1 upon nf square one upon nf square 1 upon nf square minus 1 upon ni square. Okay, this one. So this is the minus plus nf square. We have taken this this one, so there is no negative signs now. Okay, so this one. Right, nf square minus ni square. So from here 1 upon lambda value, this is important formula, guys. Okay, or we can write 1 upon lambda equal to nu bar, and that is equal to r z square into 1 upon nf square minus 1 upon ni square. Okay, this is very important formula, guys. You need to note down. We'll solve questions. Okay, so now Lyman series. If we talk about Lyman series, okay, Lyman series. If we talk about Lyman series, so in that case we know z equal to 1, obviously, right? Hydrogen we are talking about, and nf value is 1 and ni value is 1. So for Lyman series, nu bar or 1 upon lambda, that is going to be equal to r infinity for hydrogen, hydrogen and atom, that r is infinity, right? Is 1 upon nf, and 1 upon nf square means 1 upon 1 minus 1 upon ni square. This one we are putting value here. Okay, 1 upon ni square, 1 upon ni square. Okay, 1 upon ni square, where ni equal to 2, 3, 4 and so on. Okay, this one. So minimum wavelength. Okay, so this is the one, guys, for Lyman series. Okay, and for this we can write minimum wavelength also. We can find minimum wavelength we can find, right? Minimum wavelength lambda minimum is going to be 1 upon r infinity. Minimum wavelength means ni equal to infinity and nf equal to infinity. Okay, so from infinity to and nf equal to 1 for Lyman series, right? And then r minimum, that is lambda minimum, that value is 1 upon r infinity. Okay, important one. R infinity. Next is for ni equal to 2, for ni equal to 2 and nf equal to 1. So that is lambda max. That was lambda minimum, means that series limit, right, from lambda equal to infinity to nf equal to 1. Now for lambda ni equal to 2 to that is for ni equal to infinity to nf equal to 1, right, lambda minimum. Lambda maximum for equal to 2 to nf equal to 1, right. So this is lambda max value is going to be, or if you put the formula in the formula, okay, so this is going to be infinity, this one, 4 by 3 r infinity, and E is proportional to 1 upon lambda, is proportional to 1 upon lambda, okay, this we know. Lambda max value is this, okay. So now for Balmer series, for Balmer series, for Balmer series, for Balmer series, nf equal to 2, and since we know that 1 upon lambda value we know, right, so for hydrogen atom r infinity, because z square equal to 1, right, z square equal to 1, this one, so this is going to be 1 upon lambda into r infinity into 1 upon nf square minus 1 upon ni square, okay. So from here 1 upon lambda is going to be equal to r infinity into 1 upon 2 square on ni square, where ni value is 3, 4, 5, so on, okay. So now if lambda, if there is a transition from infinity to 2, means ni equal to infinity to 2, this is called series limit, right, series limit, okay, series limit. So in that case lambda minimum value is going to be, if you put the value 4 by 4 by 4 by r infinity, okay, and lambda for lambda max, this is going to be for lambda max 3 to 2, right, transition will be from 3 to 2, 3 to 2, okay, 3 to 2. In that case lambda max is going to be 36 upon 5 r infinity, okay, and that is 4 upon r infinity, right. So this is lambda max. Lambda minimum is series limit, means the transition is from n equal to infinity to ni equal to infinity to nf equal to 2 for Balmer series, okay. Similarly this one, okay. Next I'm going to solve one question, guys, okay. So this is the one. Question is, important question. 15.3 electron volt energy. 15.3 electron volt energy is given. Energy is given to an electron of H atom. 15.3 electron volt energy is given to an electron of H atom, okay, in the ground state. In the ground state, kinetic energy of free electron. Kinetic energy of free electron we need to find, okay. Since now you need to understand, okay. So we have given this 15.3 electron volt energy is given to an electron of hydrogen atom in ground state. Kinetic energy of free electron we need to find. Ionization energy means, guys, the energy which is I have already explained. Energy, the minimum energy required to eject electron from the atom, okay, to make electron free from the atom. So ionization energy is going, ionization energy for hydrogen atom we know, guys, that is 13.6 electron volt for ground state, right? And so delta E is going to be, this total energy is given, right? 15.3 electron volt minus 13.6 electron volt, okay. So that is going to be 1.7 electron volt, and that is delta E, and that is delta is kinetic energy. That is the kinetic energy. Delta E, and that is kinetic energy. Delta E, that is kinetic energy, okay. And this is the answer. So we have this energy is used for ejecting the electron, to remove the electron from the atom completely, and remaining energy is stored as a remaining energy is the kinetic energy of the electron, and that energy is that 1.7 electron. This total energy minus ionization energy, okay. This we need for H atom, okay. So this is the answer, guys. Next here, guys, I'll explain one thing here, very important concept I'm going to explain. So these are two energy level, guys, okay. These are two energy level, okay. This is n equal to 1 and this is n equal to 2, and this energy is 13.6 electron volt for this, and this is for n equal to 2 minus 3.4. This is minus 13.6 and this is minus 3.4 electron. These are the energy level for 1 and 2, okay. So there is an electron in ground state, okay. So if we this energy difference, guys, the energy difference is delta E is, this is 10.2 electron volt, okay. 10.2 electron volt. 10.2 electron volt, okay. Electron volt. So here, guys, very important concept I'm going to explain. So we have given the h nu energy to this electron, okay. That h nu energy is equal to this one. The value of h nu energy we have given, and that value is equal to 11 electron volt. So now my question is, guys, will this energy excite this electron and then electron will go to this level n equal to 2? Yes or no? No, guys, because for exciting an electron, the energy which we required is equal to that energy difference. If we will give the energy of our h nu will be equal to 10 to the power 10.2 electron volt, in that case electron is going to be excited. Okay, if we will give less than that or more than that, then electron is not going to be excited, guys. This is very important, you need to know. Okay, next second is, if this is the energy we are giving. Okay, second is, if we have send an electron of energy 11 electron volt. Okay, so we are sending electron of energy 11 electron volt. Okay, in that case, guys, in that case, this electron will collide with this electron, and this electron is going to get excited. Okay, and this will go in n equal to 2 state. Okay, n equal to 2 state. Okay, so this is very important. So this is because of collision. Okay, so this will go into this electron. If we give energy, that h nu, that then that must be equal to this, the energy difference. But if there is a electron, and if we give that an electron is going to if electron is colliding with this electron, and the energy of this electron is 11 electron volt, in that case, just guys give me 1 second. Okay, it's important work I have got. Give me 1 second. Okay, guys. So here, but if electron of this energy collides with this electron, in that case they will collide. Okay, and the electron will get excited, and will go to that level. Okay. Okay, so this is the important concept, right? Okay, important concept. Okay, and this is called collision due to electron. Okay, this is the important concept. Now next is guys, next is you need to understand like this. So we have different energy levels, right? Okay, these are the energy level. Okay, these are energy level. This is n equal to 1, this is n equal to 2, this is n equal to 3, and this is n equal to 4. Okay, so there would be transition of electron. Like if electron is n equal to 4, so electron can go here, it can go here, it can go here, right? Can go here. Okay, can go here, can go here, can go here. Okay, or it can go this one. This one. Okay, so here you need to understand this formula I'm going to write. Okay, so number of possible spectral line spectral line. Number of possible spectral line formula is n equal to n into n minus 1 by 2. Okay, n into n minus 1 by 2. Okay, n into n minus 1 by 2. Okay, so this is the formula, guys. Very important. You need to note down. So here, suppose for I'll give example. Okay, so for n equal to 4, the number of spectral line n is going to be, that is n into n minus 1 upon 2, right? 1 minus 2. So in that case, this is going to be 4 into 4 minus 1 upon 2. That is 4 into 3 by 2. That is 6. Okay. And here number of photon emitted equal to 3 max, right? Maximum. Okay, and maximum number of photon emitted will be 3 and minimum will be 1. Okay, for n equal to 4. Next is, and I'm going to write one more important thing, guys. So since we know we have delta equal to, this formula is very important. Delta E equal to 13.6 z square into 1 upon nf square minus 1 upon ni square. Okay, this one. So this is delta E. Okay, so delta E equal to 13.6 z square into 1 upon nf square minus 1 upon ni square. Okay, this is important formula, and lambda value is 12431, okay, upon delta E, which is in electron volt. Okay, and similarly delta E is 12431 upon lambda, which is at angstrom, electron volt. Okay, so these are very important formula, guys. Okay, you need to note down and memorize it, guys. Okay, solve questions. Okay, I'll also solve questions. So delta equal to 13.6 z square into 1 upon nf square minus 1 upon ni square, and 1 upon lambda value we know. 1 upon lambda equal to r infinity z square into 1 upon nf square minus ni square, right? Similarly, delta E is equal to 13.6 z square into 1 upon nf square minus 1 upon ni square. Okay, this is the one. Okay, next is, next I'm going to solve question, right? Okay, so question, the wavelength that hydrogen atom will emit if its electron makes a transition from n2 equal to 4 to n1 equal to 2. Okay, the wavelength that hydrogen atom will emit. Okay, the wavelength that hydrogen atom will emit. Okay, if its electron makes a transition from n2 equal to 4 to n1 equal to 2. Very good question. Okay, yes, options are option A 4875 angstrom. Okay, Option B is 5000 angstrom. Option C is 42 C is 42 31 angstrom, and option D is 3021 angstrom. Okay, so this is the question, guys. So we need to find out the wavelength of that hydrogen atom will emit. Okay, that okay, if its emission, electron makes a transition from n2 equal to 4 to n1 equal to 1. Right. So so we have this formula. We can directly find out. Okay, so wavelength we need to find. We can find by this formula. Okay, so this is this one. Since we have lambda equal to 4, lambda equal to 12431 upon delta E, which in electron volt. Okay, so since delta E equal to 13.6 Z square into 1 upon NF square minus 1 upon NI square. Okay, this one, right? So from here delta E value is going to be Z equal to 1 for hydrogen atom, right? So it is 1 square, and that is 1 upon NF is 1 upon 2 square minus 1 upon NI is 4 square, right? So from here value of delta E is going to be 13.6 into 1 upon 4 minus 1 upon 16. So value of delta is going to be 2.55 electron. Okay, so this is the formula for delta E. Now we can just put the value of delta E in this form, in this expression, and we get the value of lambda. So this implies lambda value is going to be that 12431 upon 2.55, and that is going to be 4875 angstrom. Okay, this is the first method, guys, or we can also solve it by second method. This I'm also going to tell you. Second method. In second method, we have a formula that is 1 upon lambda equal to r, this is r, okay, r z square into 1 upon nf square minus 1 upon ni square. Okay, this is the formula. So 1 upon lambda is going to be r into z for for hydrogen atom z equal to 1. This is 1 upon 4 minus 1 upon 16, because ni equal to 4 and nf equal to 2, right? So from here 1 upon lambda 1 upon lambda is going to be 3r upon 16. Okay, so now 3r upon 16. Now guys, you need to know this. Okay, I'm going to tell you. So 1 upon r value, you can note down it. This is 911 angstrom, and I'll tell you how to find for Lyman series. So if you know the 1 upon r value, we can easily find the value of lambda, right? So for Lyman series, and 1 upon r, that is equal to 3644 angstrom for Balmer series. Okay, 1 upon R equal to 14580 angstrom for Paschen series. One upon R equal to 22782 22782 angstrom for fund series. Okay, this is important result, guys. You should note down. Okay, and now I'll tell you how to get it. Okay, like for Lyman series, for Lyman series, this one will take ni equal to infinity to nf equal to 1. So ni will be infinity and nf will be 1. Okay, for that, so now we'll use formula that 1 upon lambda equal to r into 1 upon 1 minus 1 upon infinity, right? This one. So this value is going to be 0. So 1 upon lambda is going to be r, that implies lambda value is 1 upon r. Okay, and this value is going to be 911 angstrom. Okay, this one. So similarly we can find for Balmer series ni equal to infinity, nf equal to 1. Okay, and so 1 upon r value we know, right? That is 1 upon r, right? So we'll put this value and then we can get for Lyman's Balmer series, fund series, Paschen series, bracket series, right? This one. Okay, so here that we have got this one, right? This is the one, this value 1 upon r, lambda equal to 1 upon r, right? R value is this, 1 upon r value is this we have, right? So so this means lambda value is going to be 1 upon r value is 911, right? So lambda value is going to be, because we have 1 upon lambda value, we have got 3r upon 16. So lambda value is going to be 16 upon 3r, right? 16 upon 3r, and this value is going to be 1 upon r value is this, so this is going to be 16 upon 3 into 911, and this value is going to be 4875 angstrom. So for that you need to know this 1 upon r value, right? And for here you can easily, for this, by this formula you can easily find out lambda equal to 12431 upon delta e, right? Delta e value formula is delta equal to 13.6 z square upon 1 upon n square f minus ni square. Okay, so this is the answer, lambda value. Okay, this one. Next question, I'm going to solve. Next question. Next question is, wavelength of first line of Balmer series in hydrogen spectrum is 6563 angstrom. 6563 angstrom. 6563 angstrom. Find the wavelength of first line of Lyman series. First line of Lyman series in the same spectrum. In the same spectrum. Wavelength of first line of Balmer series in H spectrum, in hydrogen spectrum, is this. So wavelength of first line of Balmer series is given. Okay, find out the wavelength of first line of Lyman series in the same spectrum. That's what we need to find out. Options are given. Option A, that is 1215 angstrom. Option B, 3246 angstrom. Option C, 911 angstrom, and option D, 1349 angstrom. Okay, so these are the options. Very simple. For Balmer series, first line. Okay, for Balmer series first line we know, right? That is N2 equal to 3 and N1 equal to 2. Right, for first line. I have already explained here. I will show you. This one. For Balmer series, N equal to 3 to 2, right, for first line. So for that we can use this formula 1 upon lambda 1 equal to R Z equal to 1, right? Because we are talking about hydrogen. Okay, so this is 1 upon 4 minus 1 upon 9. 1 upon N1 square minus 1 upon N2 square, right? So this value, from there we can get the value 1 upon lambda 1 equal to 5R upon 36. This is equation number 1. Equation number 1. So for Lyman series, N2 equal to 2, Ni equal to 1. So 1 upon lambda 2 equal to R into 1 upon 1 minus 1 upon 4. Okay, because for Lyman series N equal to 2 to 1, right? So from here we can get lambda value. So lambda value is going to be 3R upon 4. So from here, right, this is equation number 2. We can do lambda 2 upon lambda 1, 2 by 1, right? 2 by 1. So lambda 2 upon lambda 1, this is lambda 2 upon lambda 1, right? This one, have you made any mistake? Just give me 1 second. Okay, so this one. This is the value of lambda 1. Okay, sorry, this is 1 upon lambda 1. So from here lambda 1 value is going to be this is the one. Or we can just this. Okay, this is equation number 1, right? Okay. Next is 1 upon lambda 2 value we are going to get, and that is 1 upon lambda 2 value. This is 1 upon lambda 1 upon lambda 2 value is going to be this 3r upon this. Okay, so now we can do 1 by 2. Okay, so this is going to be lambda 2 upon 1 upon lambda 1 upon 1 upon lambda 2. So lambda 2 upon lambda 1, and this value is going to be 5 by 36, 5r upon 36 upon 3r upon 4. So we solve it. So this is going to be 5 by 27. This is the lambda 1 upon lambda 2, right? So from here, lambda 2 value is going to be 5 by 27 into lambda 1, and this value is going to be 5 by 27 into 6563. Okay, this is the lambda 1 value we have been given in the question, right, for the Lyman series, for the Balmer series, right? Okay, so this will solve it, and this is the value. So value of lambda 2 is going to be 1215 angstrom. Okay, so this is the answer. Next question I'm going to solve. Next question I'm going to solve. So 2 hours are completed. Okay. Next question. Next question is, this is the Jest question, guys. Just 2016. Okay. So if the Rydberg constant of an atom of finite nuclear finite nuclear mass is alpha into r infinity. Okay, where r infinity is the Rydberg constant. Rydberg constant corresponding to an infinite nuclear mass. The ratio of electronic to nuclear mass of an atom. Okay, options are not. Okay, so this is the question, guys. Okay, so if the Rydberg constant of an atom of finite nuclear mass is given, okay, so that is alpha r infinity. Okay, where r infinity is the Rydberg constant corresponding to infinite nuclear mass. Okay, the ratio of electronic to nuclear mass of an atom you need to find out. Very good question, guys. Okay, so guys, we know, I have already explained, r is proportional to mu. We know that r is proportional to mu for finite mass of finite nuclear mass. Okay, for the atom of finite nuclear mass. and R infinity is proportional to Me. That also we know, that is uh, for the, that is for the Rydberg constant for infinite nuclear mass, right? So from here we can, what we can do, this is important result. R is proportional to mu and R infinite is proportional to M. So from here we can find R upon R infinity, that is going to be or we can write R infinity upon R, that is going to be Me upon mu, right? And R value is given, right? The Rydberg constant of an atom of finite nuclear mass, that is given R infinity, and this is given alpha R infinity, and that is going to be Me upon Me upon Me upon mu. R infinity will get cancelled, right? So 1 upon alpha equal to Me upon mu, and mu value we know, right? That Me upon mu, since mu is, we know mu value, right? That is Me into Mn, mass of nucleus for finite, upon Me plus Mn, right? Me plus Mn, Me plus Mn, where Mn is the mass of nucleus. Okay, this is mass of nucleus. Mass of nucleus. Mass of nucleus. Okay, so this is going to be 1 upon alpha equal to Me, and this we can put the value Me into Mn upon Me plus Mn. Okay, so from here 1 upon alpha value is going to be, we'll solve it. So this is going to be Me plus Mn upon Mn. Me will get cancelled, right? This Me. So or we can write 1 plus Me upon Mn. So Mn, right? We need to find mass of electronic mass, that is we need to find the ratio of electronic to nuclear mass, that is Me upon Mn, right? So from here Me upon M1 is going to be Me upon Mn is going to be this one. 1 upon alpha minus 1, 1 upon alpha minus 1. So Me upon Mn, that is going to be 1 minus alpha upon alpha, right? This is the answer, guys. This is the ratio of electronic to nuclear mass. Okay, this one be one. Okay, this is also a good question, guys. I'm going to solve this as well. Question is, find ionization energy for He plus and Li plus plus and positonium. Okay, ion. So find the ionization energy for He plus and Li plus plus for positonium atom. Okay, so first helium atom. First we know guys, here this is important thing, we know this E ionization energy of hydrogen is minus 13.6 electron volt, minus 13.6 electron volt. Okay, 6, since n equal to 1, right, n equal to 1, because these are hydrogen like atom. Okay, so these are hydrogen like atom because these are hydrogen like atom. Helium, lithium, these are hydrogen like atom. Okay, because they have only one electron, so n equal to 1 for them. Okay, so so it means since we know E is proportional to z square upon n square, I have already told you important formula, right? So from here n equal to 1 means for hydrogen like atom E is going to be proportional to z square. Okay, very important thing. Next, so now for hydrogen atom, for helium atom, He plus, we know He, for He plus we know z equal to 2, right? So this implies E for H atom upon E for helium plus atom upon E upon for hydrogen atom, right? Is this, we know this one, E proportional to z square, right? So E is, so this is energy of helium atom upon energy of hydrogen atom is going to be z square, means this 2 square, and for hydrogen we know and z equal to 1 square, right? So from here energy of helium atom, energy of helium plus is going to be 4 into Eh. 4 into Eh means that is 4 into 13.6, that is going to be that is going to be 54.4 electron volt. Okay, this one. Next is this is the answer guys, 54.4 electron volt. Next for lithium atom, for Li plus plus we know z equal to 3, so from here E Li plus plus upon Eh equal to 3, 3 is a 9 by 1, right? So from here E Li plus 3, 3, that is going to be 9 into Eh is 4, right? Eh value we know, Eh value is 13.6, 13.6, and that value is going to be, if we calculate it, okay, so this value is going to be 122 point 122.4 electron volt. Okay, the third, for positonium, for positonium. Okay, positonium is made of electron and that anti particle, right? Electron, E plus, right? So electron is moving like this is E plus at the center, and electron is moving along this. Okay, so this is the positonium guys, very important. Okay, so if we talk about positonium guys, there's a that is reduced mass, right? Me u equal to mu equal to me into me upon me plus me, because positron and electron mass is same, right? So this is going to be this, right, 2 me and this me by 2. Okay, so now we know, since we know that E is proportional to R, I have already found, and R is proportional to mu, right? So from here we can write Ep upon Eh, hydrogen of energy of positonium upon energy of hydrogen, to be R upon R infinity, because here E is proportional to R and R is proportional to mu, or we can write uh, mu upon me, right? Or mu upon me means a mu upon me. Me will get cancelled. This is 1 by 2. So from here Ep, energy of positonium is going to be 1 by 2 into EH being 0.6 electron volt, and this value is going to be 6.8 electron volt. Okay, this is the answer, guys. Well, guys, there are many questions I'm going to solve in next class. Okay, time is over. And also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes, and it is going to help you to crack the exams related to physical science. And also, guys, share my lecture details with your friends so that they will also be able to watch my free live classes. Okay, and will